14.7 Tangent planes and normal lines, part 2. We left off with this problem, z equals 2x plus y squared. We wanted to find the tangent plane at the point 2, 3, which is, this is a horizontal point. The 3D point is really 2, 3, 13. And we substituted, we got this plane equation, 2x minus 2 plus 6 times y minus 3 minus 1 times z minus 13 equals 0. You can simplify this to z equals 2x plus 6y minus 9. I'll leave that basic algebra to you. That's all 8th and 9th grade math. So in any event, we get this formula for z. In the differential section, we looked at a linearization formula. We took a curvy function possibly and replaced it with a local linear approximation. This is the formula we used. L of xy equals an initial function value at x0, y0. This would give us a linearization at this point, plus the x partial, x minus x0, plus the y partial, y minus y0. These two terms right here, from here to here, were the total differential. And this basically tells us we move off the starting point. It's a starting point plus a change gives us a new function value. This is nothing more than the tangent plane. Content-wise, or pedagogically speaking, it would make more sense if we developed the tangent plane formula and then showed how that fit into the linearization formula. You can think of this as a generic formula for a tangent plane. You can just call this z, that's all. And you can kind of see where if you move z over here, it's negative. There's fx, fy, negative z. You can see that normal line formula embedded in this. So in any event, f of 2, 3, we're talking about 2, 3. F of 2, 3 is 13, that goes here. The partial x derivative is 2x, of 2x is just 2. In particular, at 2, 3, it's 2. And the y partial is 2y. Plug in 3, you get 6. And of course, x0 is 2, y0 is 3. Those get plugged in as constants. X and y stay as variables. Those are the function variables. And if you substitute L of xy is 13, plus 2 times x minus 2, that's the 2 there, plus 6 times y minus 3, that's y minus 3. And if you distribute 2, distribute 6, you end up with this. Combined like terms, we end up with z equals 2x plus 6y minus 9, which is the tangent plane formula. It's the same content in disguise. Sometimes the calculus book doesn't explain that. So tangent plane is nothing more than the linearization formula. So, okay, and that's all for part 2.